Have you ever gazed at the night sky and wondered what powers the twinkling stars? There's a simple yet profound answer to that question. The energy that illuminates the night sky, that fuels the burning hearts of stars, comes from a process known as nuclear fusion. Think of it like a stellar dance. Tiny atomic particles, lighter than a feather's breadth, come together in a cosmic ballet. These light atomic nuclei, such as hydrogen, join forces, or rather, fuse together to form heavier nuclei, like helium. This dance, this fusion, is a source of immense power, releasing enormous amounts of energy. Interestingly, this is the exact opposite of nuclear fission, where heavier atomic nuclei split apart, also releasing energy. But it's fusion that lights up the cosmos, that powers the stars, that makes our sun shine. So, what's the secret behind this stellar power? It's all about a process called nuclear fusion. Nuclear fusion, in essence, is a dance of atomic particles. This performance of nature begins in the heart of stars, where temperatures and pressures reach unimaginable heights. Picture the core of a star, a place so hot and so dense that it is unlike anything we experience here on Earth. Within this inferno, the stage is perfectly set for the dance of fusion to take place. Within this swirling cauldron of heat and pressure, hydrogen nuclei, the lightest atomic particles, are propelled towards each other. Now, under normal circumstances, these particles, both carrying positive charges, would repel each other. But here, in the core of a star, the rules are different. The intense heat and pressure overcome their natural tendency to stay apart, forcing them to come together. As they collide, something extraordinary happens. These hydrogen nuclei, under the extreme conditions, merge or fuse to form a heavier nucleus. This new actor on the stage of our cosmic dance is none other than helium, the second lightest element in the universe. But the dance doesn't stop there. The fusion of hydrogen into helium isn't just a simple transformation. It's a process that releases an enormous amount of energy. This is due to a principle known as the mass-energy equivalence, famously encapsulated in Albert Einstein's equation E.mc2. In this equation, E represents energy, m is mass, and c is the speed of light. Essentially, it tells us that mass can be converted into energy, and vice versa. When hydrogen nuclei fuse to form helium, a tiny fraction of their mass is converted into energy. And because the speed of light, c, is a very large number, even a small amount of mass can produce a vast amount of energy. This energy radiates out from the star's core, eventually reaching its surface and radiating into space. This is the light and heat we feel from our own sun, a constant, life-giving performance of nuclear fusion. And just like that, from the heart of a star, energy is born. But why does this matter? Why should we care about nuclear fusion? Well, the significance of nuclear fusion extends far beyond the realm of astrophysics. It is the process that powers our sun and, by extension, life as we know it. But its potential doesn't stop there. Nuclear fusion could revolutionize the way we generate energy on Earth. Unlike nuclear fission, which leaves behind radioactive waste, fusion's primary byproduct is helium, a harmless and non-toxic gas. Moreover, fusion requires only small amounts of fuel derived from resources abundant on Earth and in our oceans. Imagine a world powered by the same processes that illuminate the stars. No greenhouse gases, no radioactive waste, just clean, abundant energy. That's the promise of nuclear fusion. Understanding this process, mastering its intricacies, could pave the way for a sustainable energy future, free from the shackles of fossil fuels. Nuclear fusion, the power behind the stars, might one day light up our world in ways we can only begin to imagine.